Hello to all of you who've joined. We'll just give another 2 minutes and then we'll get going. We're just waiting on a couple of other attendees to join. Okay, let's get started. So good afternoon to you all. Thank you for joining this very interesting discussion that we have today. As you may know, Australia's manufacturing industry currently contributes around 100 billion to the Australian GDP annually, which is about 5% of total GDP. It employs around 900,000 Australians, or about 7% of Australians in work. There are about 47,000 employing businesses, which is about 5% of the total number of businesses in Australia. And it contributes about a quarter of the business expenditure on research and development in Australia. These are still strong figures, but we are on the end of a consistent downward trend in terms of percent of GDP from the highs of 30% in the 1950s and 60s. This is in part due to significant increases in service industries and shrinking of the Australian manufacturing footprint in favour of overseas options. That said, we are seeing signs of this changing. An Advanced Manufacturing Growth Centre report from 2017 forecasts that we can grow the nation's output by 25 to 35% above trend by 2026. Industry 4.0 and emerging technologies like IoT are providing opportunities to rethink local manufacturing methods and therefore conversion costs. Local supply chains can be more predictable, have higher velocity, and can be affordable when taking a total cost of ownership view. COVID has and continues to present an opportunity. Overseas manufacturers and supply chains were put under significant pressure, and Australians look to local solutions. There is momentum here through to the consumer that presents an opportunity. And recently, Prime Minister Scott Morrison stated, manufacturing is critical to Australia's economic future, to the prosperity of our regions, and to the capabilities that underpin the success of so many other industries. He backed this by announcing support for industry through 1.5 billion in new funding that will be invested over the next 4 years in the modern manufacturing strategy, aiming to make manufacturers more competitive, resilient, and to scale up. We have an opportunity. I'm Darren Hungerford, and I'm the chair of the Internet of Things Alliance Australia Manufacturing Sectorial Stream. I'll be facilitating the session today and I'd like to thank everyone for joining this virtual session. We have a really exciting agenda for you. The Internet of Things Alliance, for those that don't know, is the peak Australian IoT body with over 500 member organisations and over 1,000 individual participants working across 12 work streams, of which manufacturing is one, aimed at empowering industry to grow Australia's competitive advantage through IoT. But what is IoT? Internet of Things, or IoT, represents a set of technologies that allows all sorts of devices or things to interact for the purposes of automation and high quality, high speed decision making. There are loads of broad applications. manufacturing automation, throughput and quality increases, faster and more agile manufacturing footprint configuration, equipment effectiveness through predictive maintenance, supply chain efficiency through real-time optimization based on cross-supply chain tracking, energy management, monitoring and optimization, safety performance optimization, and sustainability measurement and optimization over time. The list goes on. As I said before, a contributing factor to the future of the manufacturing industry in Australia is technology, and IoT and associated technologies are game changers. In the IoT manufacturing stream, we believe the strong manufacturing industry is viable and necessary. We also believe that advanced technology is a crucial component of how we can achieve this success. That we said, we believe an inhibitor at the moment for manufacturers in understanding in Australia is the understanding of the business opportunities, understanding of the applicability of technologies, and most importantly, how to start and who to trust. In this session today, we'll focus on these things, and it's very much about how organisations can leverage Australian capability to effectively manufacture in Australia. What you hear today is a success story of 4 organisations working together to design, develop and manufacture IoT solutions in Australia. What you should take away from today is that manufacturing in Australia is becoming more viable through the use of advanced technologies and strong collaboration with capability that exists in Australia today. We can compete on a global scale. The format of today's session will be each of our 4 presenting organisations introducing themselves and discussing their specific roles in driving manufacturing solutions. The team will then be presenting a real case study highlighting one of the many success stories. We'll finish with a Q&A session where the team are keen to take questions from the group. So you'll see that there is a questions function on the GoToWebinar control panel or in your browser. I'd invite you to think about questions as we're going through the presentation and start putting them in there, or you can also leverage the chat function as well. I'll be moderating those. When we get to the Q&A session, I'll be putting your questions to the panelists and have them answer for you. So please, at any time during the presentations, please fire your questions. That would be great. But let's move into the content. So I'll be introducing each of our presenters in turn, and we'll start with Yaser Darban, who's a General Manager, Sales Strategy and Development for Entech Electronics. Entech is a 35-year contract electronics manufacturer with over 350 experts in plants in Australia and offshore. They're an expert in design for manufacturing, design for testing, and design for automation and assembly. They have strong global supply chains, access and intelligence. They have recently brought 4 major IoT projects back to Australia in 2020, and they see their role as acting as a bridge between global manufacturing and supply chains and Australia and New Zealand design, development and manufacturing ecosystem. So I'd like to welcome Yaser to turn his camera on, share his content, and over to you, Yaser, for your presentation.
Thanks, Darren. Thanks for the introduction. It is great to be here with the audience and the panelists. I'll just start the content to save time. You made a good introduction about Entech. That is basically who we are. The few key points that I wish to highlight in terms of how we can do the IoT manufacturing in Australia is when we are going to think about product development, which Ray is going to touch on that, we need to consider the global reach of the ecosystem, the manufacturing design ecosystem that we are going to use to minimize the inconveniences and potentially avoid any misstep and waste of time during that life cycle. How we can do that is not to do all the research and development internally. The best way is to use the technology partner. And it's better to use the technology partner that they are using a technology partner themselves, and they are comfortable with using other partner, and they believe in sharing, and they believe in strategic alliances and collaboration. It is a huge difference, and that is something that need to be considered. When you do that, basically you are inheriting lots of experience that can help anyone to speed that manufacturing. The life cycle of launching a new product is very short, is reducing day by day, and the lack of integration between the design and the supply chain, what is available in the market, what are the new techniques in manufacturing, what are the new approach in putting things together, that is something that slows down lots of projects. And if you miss few months, I'm not saying few years, if you just miss few months, someone else is building what you wanted to build. There are lots of people at the same time trying to do the same thing in Australia and also offshore. And the winner is the one that can do it faster than the others. So you need a segmented manufacturing. You need to avoid imbalance of inventory, and you should be able to do everything quite fast. The other point that we have here is when we are talking about the intellectual property, that is something that people, they have probably a wrong fear, I would say, that they think that offshore is somewhere that they may lose their intellectual property, but there are lots of great product and projects which is being manufactured around the globe, and there are ways to protect that IP. There are ways to protect yourself against possible threat in your IP. You need to have open mind in selecting your partner. You need to have a very clear strategy, is that what is you're looking after, and then who you're working with. If you have a right partner, you can protect yourself, and there are thousands and millions of products actually being manufactured in Asia belong to the Western European American companies. We should not limit ourselves in Australia and New Zealand from accessing that global supply chain. And that is very important. When we are talking about global supply chain, it will just help you to broaden your company perspective and drive growth. It is like opening lots of new doors to individuals and the companies. You need to consider that. It is also it's going to help you to navigate the challenges. You are not limited with what you see around you. So we have lots of good expert research institutes and like great successful companies here in Australia, but we are just 25 million, and there are 5 million in New Zealand. How much we can do and we can see is limited to our number, and we need to look beyond what we see here to be able to avoid the mistake, the challenges, and the experiences that went wrong in other parts of the world. And that again, the global partner, they can help you with that. They will bring diverse workforce, they will bring new technique, they're doing lots of R&D which you can just tap into that and take advantage. We can do everything locally, I would say in ANZ, but we need to have open mind to be able to do that. There are some cultural value when we want to look about like how to do things offshore, and those cultural value is very important. That will help you to be able to just do the things in a right way without wasting time, without regretting how the project development and the cycle of design or manufacturing is progressing, it is good to talk to partners that few of them are in this room, that they have global access, but they have base in the ground in Australia, in New Zealand. They can communicate with you locally and they can provide you that access. About DFM and DFT, I just want to briefly touch on that. When we are talking about DFM, there are thousands of pages that what DFM means and what DFT, design for manufacturing, design for test, what does it mean? In summary, I would say that you need someone to look at your product and in just like your design file, and in just 10 minutes tell you that there are a couple of changes, there are a couple of change in the direction of your design and development that can be done. Of course, the detail of that 10-minute overview is a very broad experience, that what are the material availability, what is happening every day in lots of other similar projects, and you need to talk to someone that they have this visibility. They know that where is the interruption in the supply chain. They know that where is the cost consideration in terms of selecting different material. It doesn't need to be a very big engineering team. It just needs to have some few individual experts that they have knowledge of both worlds, what is happening offshore and what is happening locally. To just wrap it up, Entech, as Darren mentioned, we have been around 35 years. We are in the medical device, aerospace, aviation, defense, IoT as one of the dimensions that we are really pushing and focusing on that. We have quite a number of good experts locally and offshore, and we have very strong supply chain. This is something that like the ecosystem in Australia needed. And we believe that Australia is not the place to just do medical device or aviation or defense, which it is high end and very expensive. We believe lots of mass production with the low cost can be done here. We just need to do it in the right way and bring the right amount of innovation. I just pass it to back to you, Darren.
Thanks, Yaser. That was great. All right, so moving on to our next presenter, I'd like to introduce Marco Tang, Australian Head of Business Development for u-Blox. So u-Blox, some of you may know, is a Swiss company. It delivers core technology and IoT applications to connect people, machines, and everything. u-Blox has had a presence in Australia since 2017. It achieved 420 million revenue in 2019, focused on automotive, industrial, and the consumer market, and has served more than 7,000 customers worldwide. It operates in 20 locations globally, has 2 offices in Sydney and Melbourne, 6 employees to support all of the Australian, New Zealand customers. Its mission is with innovative products and services, u-Blox empower customers to locate their devices and connect them from silicon to cloud. So over to you, Marco.
Okay, thank you. Thank you, Darren. Let me turn on my camera. Okay. Good day, everyone. Marco. I hope to see today's webinar to share some thoughts about supporting OZ customers to design and manufacture IoT project. So to begin with, I'm going to show some up-to-date u-Blox IoT products. So I just want to mention the first one is the Max M10S, which is u-Blox 10th generation silicon, supports 4 satellite systems concurrently and very super low power consumption. With the secure features like advanced spoofing and jamming detection. Sarah R510MAS, which is using u-Blox own silicon, Cat M1 and MB2 cellular module, building end-to-end security with hardware-based root of trust, and provides accurate positioning. NORA B106 is a cutting edge of technology Bluetooth 5.2 standalone module, support direction finding and indoor navigation, temperature range up to 105 centigrade with enhanced security function. Judy W377 is a dual mode module, support dual Wi-Fi ACAX and also Bluetooth 5.1. Also, u-Blox provides some services. For example, IoT communication as a service, which provides true worldwide connectivity with global MQTT network that works in more than 190 countries. Security as a service protects customer surveillance and data, with safety as a core value through a worldwide scalable symmetric key management system. Location as a service set a standard for reliable and fast location information, including when satellite signals are weak or absent. So, how to select IoT components from a hardware engineer's perspective? I think it's quite normal. They will think about like the features and performance on the top two, but design friendly is very important actually. The module suppliers should provide sufficient technical documentation and evaluation tools, which provide a quick access to hardware to an IoT application. Also, like availability is the one you can purchase easily from a distributor or from an online shop or from some very useful, for example, like the DigiKey. You can get the samples on the EVK very fast and to start with. Additionally, local technical support to help customer to review the schematics, troubleshooting, debugging, which can save time and cost during the development phase. Also, should put into consideration is the component stability, quality, and the lifetime. It will be embarrassing to select a part without EOL notice, or maybe only left 2 years lifetime when you just finished the design work. So from the project management, how to manage an IoT project contains several points. So the first one I want to share with you is security actually is very critical for IoT, because of millions of IoT devices will connect to the internet and stay in a field for more than 5 or 10 years. They are vulnerable to become the target of a cyber attack, and it's not only about enterprise revenues, but also reputation. Actually, some IoT regulation has been released by US, EU, Japan, and the UK. They all demand security features in device identification, configuration, data protection, local access to interface, software and firmware updates, and cyber security event logging, etc. Sooner, I think Australian government may probably implement security regulations. So just select the mainstream technology, such I mentioned like maybe LoRa, maybe BLE, Medcap 1, to lower the risk for supply chain and the future proofing. Then the manager also should think over the cost. The lowest cost should not be the only concern to allocate the BOM, subtract to design house, and find a good contract manufacturer. Certification compliance is the last step for development. Using a cellular or short-range communication module will save the cost and the time to get the certification for whole IoT device. But if you use the chip solution, customer may face big challenge on IF and the EMC test. So stick to every project timeline to deliver the product on time. Firmware updates is necessity, not matter that the features customer want to add or profile that tackles enforced. Secure firmware over the air is safe and efficient to implement. However, manager also need to think about how to migrate to the next generation with updated technology. So without any change on component form factor will bring extra benefit to save the time and the cost. So from the executive level, they might think very different. So how to minimize solution risk? Time to the market matters most products, but actually a late product launch can negatively impact revenues. Operational costs for the whole IoT solution, including maintenance, firmware update, tech host monthly charge, etc., which will go through whole project lifetime. Select partner wisely, who brings the technology, skill, experience to the business, share your values and the vision. And the most important, I think in the COVID-19 situation, the partner should be financially stable. This is very important. And the last one is the intellectual property rights issue. This is another potential risk made not very well known, or we call it fraud licenses. The fraud means fair, reasonable, and non-discrimination terms, which is adopted by cellular standard essential patent holders to sue any customer who use them in their device and receive non-fraud return. So not fully understand patent practices and managing the patent risks can make wireless device development financially risky. Patent litigations can cost tens of millions of dollars in legal fees and internal costs, substantially disrupt the business or even shut the business down altogether. That's all I want to share today, and you're welcome to reach me for any topics offline. So that's all from my side today, and I just pass to Vafa for the next session.
Thanks, Marco. I like your comments about thinking holistically when making critical choices around IoT components. And I think the audience can probably see we're putting some pieces of the puzzle together here. So we've had a electronics manufacturer and a module component vendor, and now I'd like to introduce one other part of the puzzle. So we have Vafa Shams, head of APAC for Wirepas. So Wirepas is a Finnish company with 20 years of R&D, culminating in 95 global patents in wireless mesh networking, now in the global growth stage. Wirepas mesh has been designed assuming industrial IoT at maturity and will lead to an unprecedented scale and density required with a fully decentralized architecture. Wirepas has disrupted the concept of radio coverage from infrastructure to the device itself. In a Wirepas world, the device is the network. Wirepas holds 3 world records: the largest single mesh site at 1,000 times larger than the second largest mesh, a highest density of radio nodes in 1 meter cubed without losing a single packet, and the lowest IPv6 router power consumption at 25 microamps continuously connected. And in recent news, in October 2020, the European Telecommunications Standard Institute, ETSI, announced the creation of a new global IoT telecom standard in the DECT band, so 1.9 gigahertz, based on a Wirepas contribution for massive IoT implementations. With that, I'd like to hand over to Vafa.
Many thanks for the introduction, Darren, and I hope I can deliver a good topic here. So as Darren mentioned, that my name is Vafa Shams. I'm head of APAC for Wirepas. Wirepas, as Darren mentioned, is a Finnish company. We focus on connectivity, and we established our APAC operations out of Australia in 2017. Has certainly been a fantastic journey for us. Today, I would like to start with a bold statement to generate some energy, and also my only assumption is that the audience is thinking about how to start a new IoT project. And the controversial statement that I would like to begin with is that connectivity is the most important decision in your IoT project. And surely you're wondering about, so why I'm making this statement. And I would like to say that because it will have a significant impact on the total cost of ownership. And I would like you to let me to go through some of the very large cost factors contributing to the cost of ownership that very rarely enters into the design stage, but very often at late stages could cause complete redesign of the solution. So let's start with the installation, commissioning, and provisioning task, which is from a cost perspective, one of the largest contributors, but rarely enters the planning phase of the project. In some cases, the products you design for are deployed in places that you have absolutely no idea about, because the products are actually distributed through distributors or even online. So if the deployment requires having specialist staff to be on site, say radio or connectivity specialists, then we are talking about major cost and inconvenience to everyone. On the other hand, if your connectivity technology is capable of in-band joining and provisioning like the way Wirepas allows for, then the deployment can be performed by regular maintenance people, which is quite handy. One of our most famous projects globally is the Smart Washroom project, which has been deployed at very large scale throughout Europe. And for its installation, the very same cleaning staff are used to clean and maintain the washrooms have been used, minimizing a major cost element to the overall project. Now let's pick up connectivity. So connectivity, I guess in Australia, we're quite, the cellular users have taken for granted the good coverage we have, the wireless coverage that we have in Australia. Pretty much anywhere you go, your cellular phone is connected and there is only a few black spots. The truth is that the carriers have been conducting behind the scene RF and radio planning for many years at huge costs to make this great coverage a reality. But if I asked how good is the Wi-Fi coverage in a relatively small place, such as your home or your office is today, if you're like me, I come across Wi-Fi connectivity issues in my own small home with 3 floors all the time, and that's just below 200 square meters. If that is so, think about places like a whole hospital or a university campus or an industrial warehouse, where we talk about tens of thousands or hundreds of thousands of square meters for deployment, and how difficult and expensive it would be to plan full radio coverage for exactly where the devices have to have radio connectivity. Again, if you select the right connectivity, the devices by themselves actually bring the connectivity, and every additional device which is deployed then contributes to the extension of connectivity and also makes the radio signals stronger. In other words, the devices by themselves become your network, and then you have the connectivity precisely where the business or the device needs to operate. Many of Wirepas customers come to us because of our scale, and very often they come at too late stage. The problem is that scale is not something that you can attach later, and that you need to design for scale from the very beginning. I'm always for using simple analogies. Think about it. A kitchen that is designed for feeding 100 people cannot be retrofitted later to a kitchen that can feed 6,000 people readily. It simply can't. Therefore, you always need to think about the end game and design for it from the very beginning. Whether the solution is capable of scaling to hundreds of thousands, even millions of devices at maturity, is something that you need to be very confident and secure about in the early stage, when you are designing for 20 devices in the POC phase, for instance. This doesn't mean that you have to pay the full cost of scale when you don't need it. Therefore, when the solution is at small scale and gaining maturity. Returning to my kitchen example, if the kitchen that you are designed for 100 people is not planned from the very beginning to scale to feed 6,000, then there isn't much you can do but carry out a hugely expensive total redesign at great inconvenience to you and your customers. It is a disastrous outcome any way you look at it. And similar to the scale is the case for density. The clear fact is that today, only 5% of total devices that can be connected are connected, with the 95% remainder yet to be connected later. This means whatever projects that you're designing for future deployments will have to coexist with thousands of other devices in the same facilities. You just don't see it yet. Just as you can't have endless number of people in a physical room where they are able to speak and be easily heard is the similar case with wireless devices. You just run out of wireless space, so to say, to allow additional devices to function before they are completely dysfunctional. And this is the challenge that density provides. And I'm glad to report that Wirepas technology has been designed from the very beginning to cater for density, and in fact, we have a world record for it. And one of my most favorite topics is over-the-air or OTA software updates that Marco has also alluded to. Why does it impact the cost of ownership so much? So today you have your mobile phones and getting a couple of firmware updates a year. The applications on that mobile phone are getting updates several times a day, several times a week, even daily. There is no difference in IoT. So once you are connected, you have your smart sensors in the field, have actuators connected, you need to update those devices in the field. Why? Because there could be software bugs to be fixed, or a regulation or requirement change, or a feature change from the customer means you need to update the software on the devices. However, because of where the IoT devices are actually placed in the industrial facilities and buildings, it's not possible to physically remove them to update them locally. Hence, they need to be updated remotely and over the air. Therefore, make sure that the connectivity you choose allows for over-the-air update of devices easily. So now, having said all of this, I'm just going to send this back to Darren, and Darren will call for the next step. Thank you.
Thanks, Vafa. Great. And for our last presenter, we're kind of going back to the beginning as a very key piece of the puzzle, which is going back to design. So we've got Ray Keefe, Managing Director of Successful Endeavours. The company was founded by Ray 23 years ago to bring affordable product development to Australian small medium enterprises. It has an internal core capability of electronics design and embedded software development. Focuses on design of products that are intended to be made in Australia, and it's currently starting a new project every 3 days, which is amazing. When do you have time to sleep, Ray, would be my question. But I'll hand over to you, and looking forward to understanding a bit more about manufacturing design.
Thanks, Darren. Yes, fortunately, I do get time to sleep. That's a good process issue rather than how busy we are. So what Successful Endeavours does is that we bridge the gap between a bright idea and the actual product that you can make. There's a lot of reasons why you might need someone to bridge that gap. You might not have the science skills or the engineering skills. You mightn't have specific technical knowledge you need, or you might not just have the capacity. So we also do work for other businesses that create products, but who need help in terms of the number of people or the type of work that needs to be done. And so we create the products. However, if you're stuck, then the question is always, what do you do now? So this is what the process looks like. So we start off with the idea. We do the whole engineering piece where we look at the available technology. We look at the solutions that are available. We look at their various merits. And from that, we select a technical solution, test it, and from that, we then come up with the physical side of the product, which is the circuit boards and how everything connects together. Our particular emphasis is that we do products which are intended to be made in Australia. So that means it's designed to suit Australia and take into account all of those structural costs we have here, and custom IoT is a specialty. Most of those projects we start every 3 days are some custom IoT project because somebody needs a solution that they can't buy out of a catalogue. It's really important to think about how much you're going to be investing and what the total cost of ownership is. Vafa raised the point that a lot of people don't consider what support, service, installation, all of those factors are, what they really cost you. An awkward to install product, the unit cost might actually be less than the install cost. In fact, the cost you're probably wanting to minimize are those back-end costs. So it costs you to develop a product. You need a degree of tooling and production setup to make a product. Production has its own costs. So we often get asked to minimize the bill of materials. That's not a good strategy because the bill of materials is only one component of the overall cost. An 0603 resistor might cost 0.1 of a cent, but Yaser's team might take 2 cents to actually stick it on the board. So you need to look at what your process costs are as well when you're looking to get a product which is affordable. If it's not designed around the right manufacturing capability, say IR shadowing is an example, then you can position components on the board next to really tall components that don't get heated up properly, and then you have to touch them up after you've actually put the board through the ovens. If you don't design to avoid those problems in the beginning, then the rework cost could actually double your process costs. And then, of course, after you let them out into the field and people buy them and install them and service them and run them, they can still cost you money. So you need to consider all of these factors as stakeholders in the design challenge. You also need to work out what the primary driver of a project is. Do they need performance? Do they need time to market? Or do they need something which has a cost constraint on either the delivery of the product in terms of what it costs to get to a manufactured product or its cost in the field? So we also try and understand that side of it. Most people only think about the dollar sign cost of products because that's the easy one to measure, but it's worth thinking about what the value of improving the performance is. Do you really need all those features? And what the value of time to market is. As Marco said, getting into the market quicker has economic advantages. A few stats on us. So 23 years in business, lots of different types of products across a broad range of industries, lots of projects. We've had some national and local award recognition as both a business and a technology provider. Very busy with custom IoT. We can do prototypes in-house, so there is some overlap between the front end of what Yaser's team offers and what we offer. There's often time savings in that. And although we have a relatively small in-house team, we have a large external team of collaborators. And in general, we aim for the success of our clients, which means we want to understand what success means to them. So thank you for that, and I'll hand back to Darren.
Excellent. That's great. So there are 4 presenters today, 4 organisations that, all form pieces of the puzzle around how we go about, designing, building and manufacturing products, IoT products in Australia. And we talked through sort of all their value propositions individually, but I think the key thing, coming back to what I said earlier, is the practical of how this actually occurred. And to that end, we're going to move on to a real case study. The real case study was for a client called Water Synergy Group, and it's their WaterLink product. It is a great example of collaboration between a number of organisations that was conceived, designed, and being manufactured here in Australia, locally at scale. And Ray's going to kick us off with the presentation. So at this point, we're starting at the beginning, probably at the right point for the case study at the design phase. So Ray, I'll hand back to you to kick us off into the case study.
Okay, so the WaterLink Smart Mesh Water Meter is a product that just measures pulse water meters. So it's not a new product category, but it's a new approach to that product category. So there's a number of problems with the existing solutions. The problem is often you have buildings designed without any idea of what the end customers are going to need. So the buildings are already designed, they have multiple tenants. The builder then has to go and work out how they're going to do individual metering for billing individual tenants. There's a big range of business types and they're looking for a cost-effective solution. Now, there are products on the market in this category, so why design a new one? Well, the solutions required here is they want that low installation and low maintenance cost. That means they want them battery operated, 10-year battery life, able to be installed by a plumber. So that's the level of technical installation capability that the product's aimed at. They don't want to run extra cable runs. In fact, that can cost more than the actual water meter. They want a low operating cost, which means that they don't want a product which has got a SIM card in every unit. They want a low unit cost, or low enough anyway, so they want something that's compact, integrated, efficient, and automated, and they need time to market. So therefore, use existing proven technology, don't design what you can buy, and you also need to be able to design it around parts you can buy right now so that Yaser's team can buy them and build it. So how do you go about this? Well, my personal belief is that the way that you solve problems is that you solve the hardest problems first. If you solve the easiest problem first, then your solution might actually not work for the hardest problem. And in this one, it's communications, which is the hard problem. So low unit cost, low power, low operating cost, and tolerant of any kind of installation location. So with this, we're going to throw across to Marco at u-Blox to have a look at what u-Blox brought to the table for this project.
Yeah. When u-Blox received RQ from Ray, we promote Nina B302, which is a Bluetooth 5 long-range module with onboard antenna. The BLE support very low power consumption, and the device can be used for more than 10 years in the field by using a battery. So under that, the NDA, our FAE checked the schematics and provided several comments regarding the design when first the hardware vision developed by successful Endeavours. So this is a very important practice, as no one wants to develop 3 or 4 versions for the boards, or the worst case is just found a critical bug in the production stage. So at the same time, we also provide a Bluetooth mesh binary testing package, which is authorized by Wirepas. So u-Blox is working very closely to all the parties in IoT ecosystem to contribute to our efforts. So like the design house, software companies, IoT cloud companies, and techos. We follow up the whole project design from the beginning to manufacturing, and we also joined some field tests with successful Endeavours engineers. Yes, that's all we did with, right, yeah.
Right, you're muted. Sorry, still muted. Okay, maybe I can continue saying that just guessing that we're talking about the communication costs of the projects, and we certainly agree with that. Just take into account that once that we are talking about communication costs, every IoT project could be running in the network for 15 to 20 years in the field. So with the right connectivity, you can actually drive the cost of the communication down, and then you and your customers can actually be fully secure in terms of visibility and control of the cost of the connectivity for something around $3 to $4 per device, and even less for larger scales for the total cost of the project. Back to you, Ralph. Okay. So already when we talked about density, I think and I guess Ray is going to show you later on where these meters are going to deploy. We talked about the fact that today we only have about 5% of devices connected in the world, with the 95% remainder still to come. So interference is certainly a factor that needs to be designed for. In all of the IoT solutions of today, as the case with interference only gets worse and worse as new devices sort of increase. So you need to operate, if for instance, you need to operate a fully functional IoT solution across a whole building, you can't operate in only one channel, but requiring multiple radio paths and multiple radio channels and local decision making for routing. And I guess that goes for the reliability as well. And I think that it will be backed up by your pictures of where the actual product has been deployed, Ray.
Thanks, Vafa. Sorry about the muting issue, everyone. I clicked on unmute at the same time as the organizer clicked on unmute, and I ended up muted. All right, so pressure points. Time is a pressure point in this project because they wanted to be able to install in 12 weeks. Cost is another pressure point because they're after that low cost of installation, maintenance, and a low operating cost. Performance needed to be acceptable, but that one is the one that you can trade off in this particular case. So this is not a high performance project. This is one where time to market to take advantage of the opportunity and low in upfront and then ongoing costs really matter. The cost pressures come from that installation cost. So one of the things we had here was field terminating connectors. So there's actually a little screw terminal inside the connector that allows them to hook up the pulse sensor to it. The actual module itself can be screwed into place, strapped in place, put in place on a bracket, strapped to a pipe, bolted to a wall. Pretty much they were going to make it up when they got there. So we didn't want to preclude that. 10-year battery life leads to a low maintenance cost, plus the battery itself is replaceable in the field if they need to, but they do need to open the case for that one, and a low operating cost. Now, if we look at this, SIMs typically at the moment are running at list price of $1 per month per device. So we've got 46 devices. On top of that, web services might cost you another $3 per month per device. That's very, very common. So we're at $4 per month per device, whereas with the Wirepas solution, a pair of gateways and a mesh network gets that cost down, total cost down to $10 per month. That's an operating cost saving of more than 92% over the life of the product. Since the plumbers who were installing the stuff were also paying that cost, that one really got their attention. Time pressure was the other one. So 12 weeks from hello to we want it falling off a production line is not a very large amount of time. So you have to use parts available now, design in parallel with production. You've got to understand where everyone's sweet spot is, and your technology providers have got to be reliable in supporting you and being able to deliver on the solution. Need to ask them what they need and make sure that you give them what they need. Being able to test the product on the production line is really important. That often gets forgotten, particularly in rush projects, which is why I've mentioned it twice here. Having someone like Entech knowing that the product can be tested is really, really important, because if they make one and then their customer says it doesn't work, the question is, well, is it the design? Is it the manufacturer? Is it, a component? If you don't have test capability, then you can't do that. And I'm going to hand over to Yaser now to take it from here.
Thanks, Ray. Can you hear me?
Yes.
All right. Just quickly wrapping it up, because we unfortunately we didn't contribute to this excellent case study yet, but some of the consideration that we can consider for this project or similar project, I'm going to refer back to the good example that Vafa mentioned just now, that kitchen. I never heard of that kitchen example, but that's a good example. What we want to say is that when you're thinking about building a kitchen for 6,000 people instead of 60 people or 100 people, first of all, you need to see how others probably at the moment they're building that kitchen for the 6,000 people. The manufacturing in a scale is extremely different with the manufacturing of a smaller volume. If you are making a prototype or production run of 15 or 50 or 100 or few hundred units locally, that can be extremely different from when we are planning to scale it up. And if we are just thinking about the local market in Australia and New Zealand, maybe we are fine with the smaller volume production of just few thousand. But if we are looking at emerging market, we are looking at India, we are looking at export market of Africa or other places that the cost and dollar cents, it really matters, then you need to know what you're going to face when you are scaling up. Lots of delay and problem is happening in that handover from the smaller production supply chain or manufacturer to a bigger scaled production. And you probably, anyone need to consider to use a manufacturer that has access to good intelligence and is familiar with the look-alike of the project when it's scaling up. From that earlier stage of talking about 50 units or 100 or few hundred, you need to consider certain aspect of your supply chain and production process and integration between the material, inventory, design, testing. As Ray mentioned, he is very good with the test, creating test jigs. At Entech, we are also we are very capable with designing the test jigs, which is ready for the scale production, and simultaneously we can test several devices. What I would say to just wrap up this point is the culture of your partner is very important. Are they willing to share? Are they able to share? And are you able to communicate with them and get those information that you need to consider? The communication need to be fast and efficient, and it is good to communicate with someone in your home ground, which we are sharing lots of similar value, but probably they have the visibility and they can share you some insight from offshore. And there are some consideration for certain very sensitive aspects of final assembly and testing and firmware loading and the security aspects of the project. A lot of it can be taken care of in different ways, but there are always a hybrid production option that you do lots of mass production of labor intensive part of the project in a low-cost production environment, but do the final integration and assembly locally in-house in Australia or New Zealand. Currency and exchange rate is another issue. When you are dealing with export market, you don't want to deal with the Australian dollar or New Zealand dollar, and you want to buy everything probably in US dollar and sell everything in US dollar or in euro, whatever. So you need to be able to fix that rate. And that is something that, again, a global manufacturer, someone that with the multiple production plan can help you. And we are helping our customer at Entech with that currency issue. The risk is something that has been considered significantly lately. With COVID, hit us in China first. We told our customer that they can use our production facility in Australia, and that was a big relief to them. When COVID hit us in Australia, China was open and back to production, and we could help a lot of our customer from that offshore facility. And the bushfire last year gave us a warning that something may happen to our production facility in Adelaide or other places in Australia. We need to consider the risk factor. It may not happen, but if it happens, you should not go bankrupt, and you need to have a secure supply chain and manufacturing partner with multiple locations, I would say. Back to you, Darren.
Great. Thanks. Fantastic case study. And I guess my key takeaway from this is that it definitely is possible, you know, to do things quickly at scale with a collaboration in Australia. I think of interest is sort of the speed. Definitely that you know, this product particularly had to come to market, and possibly that was only able to be achieved based on the networks that you know, that are established amongst these organisations. Now, we know from the work that we do in the IoT AA is that, you know, visibility and access to capacity and capability in Australia is something that's probably lacking outside of, you know, a few organisations that know, and something that, you know, really needs to be improved if we're going to, you know, continue to ramp up how we manufacture in Australia. So I think that's a key point I took away from that case study. We have time for some questions. I've been checking the question pane. If anyone does have questions, I'd ask you to start putting them in, and we can start getting the panel team to start addressing. Ask the panel team all to turn your webcams on now.
Yeah, actually, I saw a question from Rick. He has a specific question about Sarah Alpha. Yeah, okay, that's a good question. So Sarah Alpha will be available to just provide the Telstra approval in Q2. That's what we planned. But the features is they're supported by Telstra network. Yeah, that's already to be published. And also, yeah, because we are using the Sarah form factor for the R4 and R5, so it's very easy. Customer can do the migration to replace that. You know, it's not possible just to remove the module from the existing PCBA and just throw away and replace a new one, because this is very usual when the customer already done a PCB and they just reuse that PCB for some other purpose. Yeah, sorry about that. Yeah, and I also see another question from Fabian. Is how to compensate for components cost delta in Australia when you want to manufacture locally? I think maybe this Darren or Yaser can help to answer.
Sorry, what was it? Can you repeat? Maybe only you can see the questions, Marco. So I'll get
No,
you
I
to.
think it's just in the question session.
Sorry to interrupt. Ray, I think your screen sharing.
Oh, sorry. I thought you had put us on multi-camera view.
Mm-hmm.
I was following up on something Vafa asked me for.
Thank you.
Okay.
So what was that question, Marco, for the team?
Yeah, so Fabian asked the question, so how to compensate for components cost delta in Australia when you want to manufacture locally?
Okay, how do you compensate from the component cost delta in Australia when you want to manufacture locally? So Yaser, did you want to have a go at that first?
Sorry, I didn't get the question. Can you repeat how to compensate?
Compensate for component cost delta when manufacturing in Australia.
I'm not sure. What does it?
I can have a go at that.
Yeah,
I can have a go at that.
Yeah. Okay, Ray, go for it.
Yeah, so Australia is never going to be the cheapest place in the world to make something, because we have different business costs, different structural costs, and there are actually overheads to getting components to Australia. So depending on where they're supplied from. So if you're working with someone like u-Blox, they provide world pricing. If you're working with someone like TI, they provide world pricing. So if you're doing comparable production runs in Australia to overseas, you'll get offered the same pricing for those components. So if you select the right components from the right vendors, you can minimize some of those differentials. But what you'll never do is get a product at the same cost of manufacture that a number of the, say, particularly the Asian supply chains will offer. What you will get in Australia is a product that works, a product you can return and get fixed if it breaks, a product that actually has support and follow-up, and a product that's actually been designed to standards and which can be proven to be designed to standards. So if you don't need it to work, or you don't really care about what happens to it after it goes out into the field, then you can buy it from anyone. If you really want it to work, then you've got to think about your supply chain and who you're going to partner with. Just buying PCB assembly on price isn't the only cost that you've got to consider. You've got to consider all of those total costs of ownership. So if the product matters and you need it to work and you want it to last for 10 years, then you want to consider those other cost factors, and that's where Australian manufacturers can really shine.
Okay, great. So keep those questions coming, and Marco, I'd ask you to keep an eye on the question panel. In the absence of other questions from the floor, I have a couple to pose to the group. The first one, probably coming back to a bit of the introduction around some of the things that have changed recently, I'd like to get a perspective on the main message that we got from the manufacturing industry in Australia out of COVID-19 and the you know what happened during that period around local production versus offshore manufacturing. Yaser, would you like to start?
Oh yeah, sure. Basically, despite of, I would say that's a very good question, relevant question to the current climate that we're facing. What we feel at Entech is that COVID and the way that we were all hit with the manufacturing and supply chain issue proved to us that the actual resilience that we need in dealing with this sort of situation is not to do everything in-house. It is to have more friend, more strategic partner, like the people in this room, that they have global presence, and whether it's a supply chain, whether it's a design capability, it's just that more connection can help us to achieve the issue much faster and recover from all sorts of delay in the production and the normal routine of doing the business. So I would say that what we took from that COVID, and I think JBIL, which is one of the biggest contract manufacturer in the world, I was reading an article recently, they run a Q&A sort of survey with 700 global decision maker in terms of supply chain, and 40% of major company around the world, they said that they are adjusting their sourcing strategy to have more global connectivity. 30% of them, they said that they're expanding their EMS partnership rather than doing everything themselves. They're looking for a more established partner that they can get the pressure in this sort of situation instead of them getting the major hit. And 53% of them, they said that they're looking for a manufacturing partner, not just the electronic. Someone, I would say, like Entech, that we can do the electronic and also we can do the complete production of the project and do the whole supply chain recovery. I'm saying that we need to reconsider our approach in manufacturing and have more strategic partnership to be ready for the next pandemic.
I think that's a fantastic insight. So partnership strategy for resilience, I think sounds like an interesting takeaway out of this situation. Also, probably one for you, Ray, just about, if we had to sort of boil all the lessons down into one, is there one key thing that organisations should consider when making an IoT device in Australia?
I think it depends on the organisation. If it's the government, I'd say the key consideration now should be that local jobs actually matter. That's something we really learned in COVID, and nothing generates more local jobs around it than manufacturing. So manufacturing as a strategic builder of the Australian economy should be definitely back on the agenda. In terms of individual organisations looking at stuff, I'd say do your business case properly and sit down and look at all of the costs of the product. What is going to be the cost of communications over the life of the product? How are you going to support it in the field? And what are those costs going to be looking like? What do the design costs look like? What do the manufacturing costs look like? And do that total cost of ownership analysis, because that will get you away from thinking around how can we minimize design cost? How can we minimize bill of materials? How can we minimize, production margins? Back to a more holistic view, which is what is the total business case for this opportunity? And then you can start to look at, well, maybe u-Blox as a premium module supplier, they may not be the cheapest Bluetooth module on the market, but if you want one that works every time and you don't want to spend 100 grand sorting out all the mess, then they may be a really good solution for your project. Same with Wirepas. There's a single cost per module upfront for what they offer as a solution. There is no cellular, LoRa, or other provider on the planet who can compete with that value proposition when you put it in the right context. So understand your business case.
It's fantastic advice. Marco, any other questions from the group?
Yes, I see another one. It's popped up. They are just asking about smart building, and it's currently they are using the Cat M1 technology, and they just want to ask if they can use maybe LoRa or some long-range Bluetooth or something else. I think maybe Vafa or Ray can help to answer the question.
What was the application again?
I think basically what smart
building, yeah.
Okay.
So what Ray said previously, I think that's equally applicable to this question. And depending on the scale and density, I would go for a mesh solution for a smart building, which, in my opinion, is a standard for within buildings. But then and then also from a cost perspective is a bit more of efficiency. Don't know what you think, Ray?
Yeah, if you're designing a smart building from the ground up, you would wire everything in because that has some advantages. And then you'd only be dealing with stuff you didn't think about at the design phase. My experience is that most smart buildings are designed really dumb at the beginning and you have to add the smart afterwards, at which point the installation cost becomes a big issue. Running an RS485 feed is actually more expensive often than the sensor that you want to install. Our experience in smart cities is the cost of the electrician to put a power point in is actually more expensive than the sensor you want to install. So if you're doing smart city and smart buildings as an afterthought, then wireless mesh networking has a fantastic value proposition because it really makes that installation piece, commissioning piece, operating piece work really well. It's also got fault tolerance. One thing people don't think about with RS485 cable runs is someone cuts your cable and then someone's got to go and repair it. Whereas with Wirepas, if someone puts another steel bulkhead in something, the mesh network will route around it using the available devices. So the cost of maintenance over time is also better.
I would just add a small point on this is we have seen some example of our clients dealing with different market when they're developing their IoT project and product. And for each of these markets, sometimes they're using a little bit of different connectivity. And our advice to them, based on what we see, is that try to make it modular, your design and development, so you can make some adjustment in terms of connectivity if you're going to export to US or to Africa or to Australia. Be a little bit flexible and comfortable to make adjustment. You don't need to redesign the whole thing. I think Ray can contribute to that, but that is a consideration. Don't just look at the current market of Australia and New Zealand. Just think a little bit more wider for the future.
Yeah, I agree. Think global.
Think global, act local. No. All right, so we're coming up to time. I'm conscious of people's time. But I will just, we might have time to sneak in one more question. We've got it maybe 1 or 2 minutes. The last question I posed to the group, which I think is probably a really important one to wrap up the conversation, is how is it possible to compete with a global manufacturing supply chain? Maybe I'll get your insight on this first, Ray.
Yeah, so I think this one also comes back to the business case side of things and what you're doing. In Australia, we're never going to compete with a large offshore volume manufacturer if we're only a piece of the market. So as an example, if you've got somebody making a million parts a year of some particular appliance and the Australian market is 10,000 of those pieces, then trying to go up against those 10,000 pieces in Australia with a 10,000 piece solution is not the answer, because they've got the buying power and they've got the volume logistics. So if you're going to compete with a volume global opportunity, think volume, think global, because the machines cost the same, the parts cost the same. If you get the automation right, and if you design it so that it falls together, it works every time, it's testable, it's supportable, then you can beat them on total cost of ownership.
Darren, sorry, I know we are running out of time. In the beginning, the introduction, you mentioned that as a fact, Entech brought 4 big projects from offshore back to Australia in 2020 during pandemic. One of these particular projects we are making, I can't say exactly how much, but hundreds of thousands of electronics device per month for that particular project. And we have been doing that in our offshore facility. It is quite different, the cost of labor here, but when we are bringing the right amount of automation, and we invested heavily in that automation from the beginning, from assembly to testing to packaging, we can do lots of automation. It doesn't defeat the fact that we want to create job locally. Still, those automated machines need operator to run them, and we are creating job by doing that. But at the same time, we are able to compete with the production cost of offshore project, and we think it is achievable. And what we want to do is to share this knowledge of automation with all the design houses in Australia and New Zealand, and tell them that let's design it this way, and we can scale up and compete with the global manufacturer. Excellent,
thank you. And I know we're at time, so we might just leave it there for questions. But in closing, I guess we're at the end of our session today. Thank you all for your time and your considered questions as well. Special thank you to our 4 presenting organisations, Entech Electronics, Successful Endeavours, u-Blox and Wirepas. The intent of today was to demonstrate that there is capacity and capability in Australia to manufacture successfully, competitively and at scale. This was only a glimpse though. We only, we talked through one case study and we gave a brief impression of the perspectives of a few organisations that are here. Hopefully though we've sparked interest and sparked you to want to know more. If that's the case, please reach out to our presenting organisations, and also I would say, if you are interested, please reach out also to the IoTAA at iot.org.au to continue this conversation. I think Ray, you're going to leave the team with the contact details of each of the organisations. Is that right?
Yep, I've got them. I just need to share my screen.
Okay, well, share your screen and I'll wrap up there and say goodbye. Thank you everyone for your time.
Thank you for attending.
Thank you. Thanks, Darren.
Thanks, everyone. I don't seem to have screen share, Marco.
Yeah, give me a second. Yeah.
Technology, gotta love it. There you go.
Thank you.
Thank you.
Thanks, everybody. Have a great day.
You too. Cheers.
Bye.
Yeah, bye.